Hello and greetings everyone. I know you guys must be wondering who I am. So, first thing first, let me introduce myself. I am John, your new mathematics teacher. Nice to meet you. I heard that some of you might facing problem in solving question related to ordinary differential equation. But no worries. I am here. I will guide you on how to solve these questions by using the easiest way and help you to understand better. Without wasting time, let's go to question number 1. Let's say, if we have this question. As you can see, the question is, a steel ball, weighing 2 pounds is dropped from a height of 3,000 foot with no velocity. As it falls, the ball encounters air resistance numerically equal to V/8 in pound. The V in the question is denotes by the velocity of the ball, which is in feet per second. In order to understand the question clearly, I would suggest you to interpreting the question into a situation. So, for situation number 1, let's imagine if we have a steel ball. From the question, it says that a steel ball weight 2 pounds, are dropped from 3,000 feet height. At altitudinous height, the steel ball encounters air resistance which is equal to V/8. V in the equation are denoted as velocity of the ball, where we measured the value in feet per second. I hope by interpreting the question into the situation just now, can help you to understand better. By assuming the gravity is 32 foot per second square, let's find the solution for A, the limiting velocity for the ball, and B, the time required for the ball to hit the ground. First question, what the limiting velocity for the ball? Firstly, you need to come out all the information given. After that, assuming gravity is 32 feet per second squared from the formula W equal to F equal to mg. Then insert all the information into formula of gravity. We get m equal to 1 per 16. And as we know, the standard form of linear differential equation is d per dx plus p, x, y equal fx. So the standard form for this question is dv per dt plus 2v equal 32. This is first order linear differential equation. Then determine the general solution using an integrating factor. The solution can be compactly written as from the calculation we get c equal to -16. So the three differential equation become Vt equal to -16 exponential power of -2t plus 16. So the limiting velocity for the ball is 16 feet per second squared. The second question, what is the time required for the ball to hit the ground? To find the time it takes for the ball to hit the ground, x equals 3,000, we need an expression for the position of the ball at any time, t, since v equals dx/dt. It can be rewritten as this by using the equation we got in question, A. Integrating both sides of this last equation directly, with respect to t, so we will get this equation, where C1 denotes a constant of integration, at d equals 0, x equals 0, substituting these values into the equation. So, it can be concluded that C1 is equal to -8. By substituting the value of C1, we will get this equation. So, it can be solved into this. Or, like this. Although, it cannot be solved explicitly for t. A good approximation is obtained by setting 2t equals 376, or t equals 188 seconds. That all for question number 1. Bye bye. Oh yeah! We have done with question number 1. Now, we can proceed with the question number 2. Before we find the solution for the question number 2, let me tell you the situation for the question in detail first, so that you can understand it clearly. As you can see, here is a 50-gallon tank. Initially, a 50-gallon tank contains 10 gallons of fresh water. At D equal to 0. A brine solution containing 1 pound of salt per gallon is poured into the tank at the rate of 4 gallons per minute. Then, the well-stirred mixture leaves the tank at the rate of 2 gallons per minute. So, basically, the question number 2 is: a 50-gallon tank initially contains 10 gallons of fresh water. At D equal to 0, a brine solution containing 1 pound of salt per gallon is poured into the tank at the rate of 4 gallons per minute, while the well-stirred mixture leaves the tank at the rate of 2 gallons per minute. From the question given, we need to find A. The amount of time required for overflow to occur. B. The amount of salt in the tank at the moment of overflow. First question is how to calculate the amount of time required for overflow occur. Let ST for the amount of salt, in pound at time t. ds/dt equal rate of salt into tank minus rate of salt out off tank. ds/dt equals 1/4, 2's divided 10 plus 4 to 2t. The differential equation is ds/dt plus s/5 plus t equals 4 and s0 equals 0. Integrating factor mu equals 5 plus t, 5 plus t ds/dt plus s equals 4 5 plus t, 5 plus ds equals 20t plus 2t square plus over 5 plus t. Integrate ds5 plus t equals integrate 4 5 plus t dt, 5 plus ts equals 20t plus 2t square plus cs equals 20t plus 2t square plus c divide by 5 plus t, so c equals 0. So then, st equals 20t plus 2t square per 5 plus t. S equals 10 plus 2t equals 50, t equals 20. Thus the tank overflows at t equals 20 minutes. Next, we will be answering question 2b. To answer the question, first let S be the amount of salt, in pound, at any time t. For the rate equation, based on the principle, ds over dt equals rate of salt into tank, minus, rate of salt out of tank. Thus, ds over dt equal to 1 times 4 minus 2s divided by 10 plus 4 minus 2t. So we simplify and we get the differential equation, ds over dt plus s over 5 plus t, equal to 4. Consider this as linear. So for integrating the factor which is 5 plus t, we get d, 5 plus t, time s, equal to 4 times 5 plus t, dt. Then, integrate on both sides. On the left side, we get 5 plus t times s, and on the right side, we get 20t plus 2t square plus c. So, s equal to 20t plus 2t square plus c divided by 5 plus t. Substitute s at t equal to 0, we get c divided by 5 equals 0. Therefore, the final equation will be st equal to 20t plus 2t square divided by 5 plus t. As we know, the tank overflows at t equal to 20 minutes. So, substitute 20 into the equation, then we will get the answer as shown here. Therefore, the amount of salt in the tank at the moment of overflow is 48 pounds.